Welcome to the inverse Laplace transform. So recall the Laplace transform of f that is defined by the Laplace transform of f of t was equal to capital F of s, which was the improper integral from 0 to infinity of e to the negative st times f of t dt. The inverse Laplace transform essentially takes our capital F of s and takes it back to our lowercase f of t. So the inverse Laplace transform takes our capital F of s back to lowercase f of t. So in other words, the inverse we denote just like inverse functions. We take our script L and then do our to the -1, indicating inverse. The Laplace transform, the inverse Laplace transform of capital F of s is equal to f of t, where the Laplace transform of f of t is that capital F of s. It turns out that the inverse Laplace transform is an operator. We can do this as long as we recognize the capital F of s. So we will use the table to find the inverse Laplace transform. So we'll start off with a couple simpler examples where the function is already in the form that we need it to be in for our table. And then in future videos, we will see kind of how we can manipulate our f of s to get it into a form that we can use. So let's find the inverse Laplace transform of 1 over s minus 2. Note that this form, so this takes the form (1 over s minus a). So what we need to do is we need to identify that form on our table and then go back to the original function. So switching over to our table, we have that 1 over s minus a came from e to the at as our lowercase f of t function. So this is what we will want to use. So here's what we were looking at. This is our capital F of s on the right, and on the left is our inverse Laplace transform of capital F of s. So this time around, we're essentially working our way backwards across the table instead of forwards. We were given a case where a was equal to 2. And so we will take 1 over s minus 2, and it will go back to e to the 2t. So what we get is the inverse Laplace transform of 1 over s minus 2 is simply e to the 2t. Similarly, let's go ahead and take a look at the function capital F of s is equal to 2 over s plus 1 squared plus 4. So this takes the form omega over s s minus lambda squared plus omega squared. Here we're taking lambda is -1 and omega is 2. So if we check out our chart or our table of Laplace transforms, we look through our table, we do have an omega over s minus lambda squared plus omega squared. That corresponds to our e to the lambda t sine of omega t. So again, going back to our notes. Again, we have our f of s on the right. And we're going to the left, gives us the inverse Laplace transform of capital F of s. We had lambda equals -1 and omega equals 2. So we were looking at 2 over s minus -1 or s plus 1 squared plus 2 squared should take us to e to the lambda t. So e to the -t times sine of omega t, so times sine of 2t. To update my screen. So there's our e to the -t sine of 2t. And this gives us then the inverse Laplace transform of 2 over s plus 1 squared plus 4. That inverse Laplace transform is simply e to the -t times sine of 2t. So anytime we're doing the inverse Laplace transform, you want to use the table. We're trying to force our sort of f of s function into a format that looks similar to the right-hand side of the table, and then we can backtrack to the original f of t from there. In the next videos, we will have to do a little bit more manipulation to get our function into a form that we can recognize.